7-9 is called perfect squares. It starts on page 450. Factoring perfect square trinomials is a little bit tricky, and frankly, it's just kind of annoying to do it this way. If it's a multiple choice test, would probably use the answer choices and multiply them out to see which one gives me the answer in the problem. So for example, if they want me to factor this problem, I would use the answer choices, multiply those, and then whichever one gives me the correct factor, whichever one gives me the correct polynomial here, that one would be your correct answer. So whichever one you want to do is fine with me, but this one, the first is saying, is it a perfect square trinomial? So first we have to decide, is it a perfect square trinomial? And then if it is, we factor it. So a perfect square trinomial is set up like a perfect square here and a perfect square here. And then the middle term would be 2 multiplied by the square root of both of these end terms. So to figure out if this is a perfect square factor, we have to decide what A is and what B is. So if this is my polynomial, my A would be the square root of this. So my A would be 3y, and my B would be 16, the square root of 16, which is 4. Okay, and then the middle term has to be equal to A multiplied by B multiplied by 2. So if I were to do A multiplied by B multiplied by 2, in this case 3 times 4 times 2 would give me 24, and then I have a y. So because the middle term 24y is the same as A times B times 2, this is a perfect square trinomial, and I can factor it like this. So because it's all plus, it would factor into A plus B, or A plus B squared, which is the same thing. So my perfect square trinomial here would factor into 3y plus 4 squared. Or I could also write it 3y plus 4 multiplied by 3y plus 4. These are the same thing, and either one will be correct. So that's it for that one. For this one, we again have to decide if it is a perfect square trinomial, and then if it is, we can factor it. But if you look here, 2a squared, this is not a perfect square, and so this is not a perfect square trinomial. So we're not going to be able to factor it that way. Now you might be able to factor it by doing your x and then multiplying a times c and all of that, but you cannot factor it using a perfect square trinomial theorem. Okay, so here, these are just two that we have to determine if they are factorable or not. So if we look at this one, it's definitely factorable by taking the greatest common factor. So 2 would be our greatest common factor here, and we would be left with x squared minus 16. So then once we're finished factoring out the greatest common factor, which is always our first step when we're factoring, then we can also see that inside the parentheses here we have x squared minus 16. X squared is a perfect square, and negative 16 is a perfect square. So, and it's a minus sign, so this is a difference of squares, which was what we did in 7-8. And we know that we can factor this into x plus 4 and x minus 4. And we still have the 2 out front. So after this, we look and we see there's no more squareds or anything like that. So on this one, we are finished with that. On this one, there's no greatest common factor. And this is not a perfect square, the first term. So we can't do anything as far as perfect square trinomials, and it is a trinomial. It's not a difference of squares, so we can't do the difference of squares. The only thing we can try to do is multiply 12 and 25, which would give me a negative 300 and then a 5. But there's no numbers that when I multiply, I would get negative 300 and add to get 5. The closest I can get is a difference of 10 here with like 15 and 15, but we want 5 for when we add them. So There's nothing that I can pick, so this is called a prime polynomial. I cannot factor this polynomial. Now, I can find the solution of it technically if I have an equals 0, but I would have to use the quadratic formula. Okay, on this one, we have a squared plus 12a plus 36. So first, I'm going to look for greatest common factor, but I don't see any greatest common factors because a squared has no number in front. So there's no number, and they don't all have a's, so there's no greatest common factor. It is a trinomial, so I can see if it's a perfect square trinomial. And so if it's a perfect square trinomial, that means that my a, in this case, the square root of a squared is a. And my b, the square root of 36 is 6. And then if I did a multiplied by b multiplied by 2, I do get this middle term. So this is a perfect square trinomial. It's all positive, so that means that when I factor it, I would get a plus 6 and a plus 6 equals 0. Now I want to find the solution because it has equals 0, so I'm going to set each of these equal to 0. It's the same factor, so I don't actually have to set both. I'm just going to do a plus 6 equals 0 and solve the equation. So a is equal to negative 6. So negative 6 is my only solution here. So if I were to graph this polynomial, what it would look like is first it's a positive, so it opens up, but it would open up at negative 6. And so it would look something like this. It would only have one solution at negative 6. On these, if I were to set this equal to 0, it would have a negative 4 and a positive 4 solution. So this one would look something like this. Okay. So solutions are the same thing as roots. It's where your graph crosses the x-axis. We don't have a graphing calculator, so it's difficult to kind of see that, but one solution and then two solutions here. Okay, this one here again, it's a trinomial. So first I'm going to look to see if there's greatest common factor, and there is not. Then I'm going to look to see if it's a perfect square trinomial. This is a perfect square, and this is a perfect square. So my a is y. My b is the square root of 4 is 2, and the square root of 9 is 3, so this is 2/3. So then my a times b times 2 gives me 4/3y, which is the middle term here. So my factor then would be y, and it's a minus in the middle, so it would be y minus 2/3 and y minus 2/3, or y minus 2/3 squared equals 0. So then I'm going to take it and set it equal to 0. So y minus 2/3 equals 0. I'm going to add 2/3 plus 2/3. So I get y equals 2/3 for my solution. And perfect square trinomials will only have one solution. This next one, a minus 10 squared. Because it's all of this side is squared, to solve, I can actually just take the square root of both sides. So here I have a minus 10, because the square root will just get rid of this 2, equals. Now, because it's a squared, that means this could equal a positive or a negative, because a negative squared is the same as positive. So what I'm going to do is actually set this equal to a positive 11. The square root of 121 is 11. So I'm going to set it equal to a positive 11, and then I'm going to set it equal to a negative 11, because both will be solutions. Then I'm going to solve the equations. So this is plus 10. So I get a equals 21. This is one of the solutions. Plus 10. A equals negative 1 is the other solution. So I have two solutions. One is positive 21 and one is negative 1. And this one is the same type, except for when I take the square root here, 26 will give me a decimal. The square root of 26 will give me a 5.009. So I have z plus 3 equals a positive 5.099, and z plus 3 equals a negative 5.099. So I subtract the 3, and I get z equals 2.099, and z equals negative 8.099. So these are my two solutions here. Okay, then I'm finished.